Applications of logarithmic scales. So some examples of log scales are earthquake intensity. Everybody's heard of the Richter scale, right? Sound intensity. Everybody's heard of decibels. And Foot scales. Everybody's heard of Foot scale. Well, it's, I don't know, Foot, pH. Everybody's heard of pH scales. And it's not. There won't be any questions on there that require you to have taken Chem, right? So you're not. If they are going to use pH in a question, they'll give you the formula for it. Okay, as will we. All right. So probably the most famous log scale is earthquake intensity, and it's the Richter scale, named after a guy named Richter.
What if his name was Ricky?
His name was what?
Ricky.
Ricky. It'd be the Ricky scale. There's the Beaufort scale, that's for wind. There's the Beaufort scale, that's for wind. It's not logarithmic, but it's named after the guy who invented the scale. There's Fahrenheit and Celsius, named for the guys who... Anyways, a Richter scale is used to measure the intensities of earthquakes. When the intensity of an earthquake is measured, it's compared to the intensity of an explosion of 14 kilograms of TNT. Like, why they, that's just some arbitrary, I don't know where they came up with, like, why 14 kilograms.
Scale, because Nobel invented TNT.
Yeah, I don't know. Which is referred to as the reference intensity. So in other words, they could set up a seismograph, blow up 14 kilos of TNT and see how it registers. Okay? And that's called the reference intensity. And then everything else is compared to that. But it's a logarithmic scale, so an earthquake with magnitude 1 on the Richter scale is 10 to the 1, or 10 times, as intense as the reference intensity, sometimes referred to as tenfold. So if it was a 2 on the Richter scale, how much more intense than the reference intensity? 100 times, right? 10 squared. 3 on the Richter scale would be 10 cubed. So we start getting into these 7.2 magnitude earthquakes, that's 700,000 million. That's like 10 million times more intense than 14 kilos of TNT going off, right? Which I guess we would have to go out in the field and set it off to see what it felt like, and then say, wow, so this is 10 million times more intense than that, right? If you're dealing with this 7.2. Okay, so if we had an earthquake with the magnitude of 7.2 on the Richter scale, it would be 10 times more intense than the magnitude of what? So where would we be on the Richter scale if we were 10 times less intense than 7.2? 6.2, right? Because every movement of 1 on the Richter scale, and it would be 100 times more intense than an earthquake with magnitude of 5.2. So in Calgary, occasionally we do get earthquakes. You don't really feel them because they're fairly low intensity, right? Low magnitude, but it still would be like magnitude 4 or 5. It might rattle dishes or something like that.
Really, in Calgary?
Yeah, really, Calgary earthquakes.
Never felt that.
I know, because they're not that intense. Magnitude of an earthquake is measured using the Richter scale is given by the formula m. So magnitude is log I over I naught, where I is the earthquake intensity and I naught is the reference intensity, right? The 14 kilos of TNT. 1 to the magnitude. How about the magnitudes of 2 to the magnitude? The magnitudes of 2 earthquakes are M1 and
That's
M2. Yeah, I know. It's written on my sheet and it's up there too. So
it's changed.
Oh, it's changed. The magnitude. Nice. Somebody changed it. I have old keys. The magnitudes of 2 earthquakes are M1 and M2. Use the formula above to show the ratio of the intensities of the 2 quakes. I1 over I2 is equivalent to 10 to the power of M1 minus M2, where the first earthquake has an intensity of I1 and a magnitude of M1, and the second one has an intensity of I2 and a magnitude of M2. Here we go. So the takeaway is this. This is the important thing. If you are dealing with log scales, the difference in intensities is simply 10 to the power of the difference between the measurements on the scale. Okay? That's Okay, that's the takeaway. But we're going to show mathematically why is that, right? So we've got magnitude of m1. So we've got a formula. So m1 is equal to the log of I1 divided by I naught. And m2, so we're just plugging into the formula, right? m2 is the log of I2 divided by I naught. Remember I naught is the reference intensity. And every earthquake is, you take the intensity of the earthquake compared to that, right? So you divide it. How many times more intense, then you take the log of that. All right, so if we convert this from a log to an exponential, right? Because, like, what use is this? But the base is 10. So 10 to the m1 will be equal to I1 divided by I naught. And similarly, with m2, then 10, oh, wait, and if we solve for I1, so solving for I1 is equal to, where do I write this? 10 to the m1 times I naught. And similarly for m2, again from log form to exponential, 10 to the m2 is equal to I2 over I naught. And so intensity 2 is equal to 10 to the m2 times I naught. Times in there. So now if we compare the ratio of intensities, right, I1 over I2. So I1 over I2 is equal to, okay, so I1 is 10 to the m1, I naught. I2 is 10 to the m2, I naught. The I naughts cancel, right, because they're the same reference intensity, right? Each earthquake is measured against that reference. We're left with 10 to the m1 over 10 to the m2, which is 10 to the m1 minus m2. Okay? So the takeaway really is, if you give me two earthquakes to compare, I'm just going to go 10 to the power of the difference between the intensities, and that will tell me how many more times one earthquake is than the other. But if they're one apart or two apart, I don't need to do this. I'll know that it's 10 or 100 or 1,000 or so on. So here we go. The earthquake in Japan in 2011 had a magnitude of 9.2. I think that was out at sea though, right?
Yeah.
Like not, because on land, 9.2, like there's nothing standing, right? Like if a
Wasn't there,
9.2
like, a really
earthquake
bad
hit
one
here,
in Chile?
there would be nothing left standing.
Wasn't there one like that in Chile? Like, I don't know
The
if-
Chile earthquake was around like 8
Eight,
something,
yeah.
I think, and so you think 9.2 could be 10, 20, 30 times more intense. So if you actually look at the, if you go online and look at the Richter scale, like on Wikipedia or something, it'll describe sort of the what you can expect.
Comments.
Matter of fact, why don't we just, let's pause. Okay, so Japan 2011 magnitude 9.2, earthquake Guatemala had a magnitude of 7.5. How many times more intense is one than the other? So you could say intensity in Japan divided by the intensity of Guatemala is 10 to the power of the magnitude of Japan minus the magnitude of Guatemala, which is 10 to the 9.2 minus 7.5, which is 10 to the 1.7, which is about 50.1 times as intense. Okay, so 50 times. So, I mean, the key, if you're just given a multiple choice question, it says how many times, just go 10 to the power of the difference between the magnitudes, right? And magnitudes are just the measurement on the scale. So it's the same thing with pH, it would be the measurements on the pH scale, right? Although they go and mess that up because of where acid and base and stuff go. So a more difficult question, instead of just straight how many times more intense, an earthquake in town A had a magnitude of 3.5. Determine the magnitude of an earthquake in town B if it was 1/3 as intense as the earthquake in town A. Okay? So if we take intensity of B over intensity of A, which will be 10 to the power of the magnitude of B minus the magnitude of A, which is 3.5. Let's just write this as magnitude A for now. Okay, and we want that intensity to be 1/3. So 1/3 will equal 10 to the power of the magnitude of B minus 3.5. Okay, so it's a little more complicated to solve, right? We want to solve for an unknown exponent, which means we're going to take the log of both sides, right? So you're going to go log of 1/3 is equal to the magnitude of B minus 3.5 times the log of 10. Okay. Now, the nice thing about using log when you've got a power of 10 here is that log of 10 is equal to what? 1. So that's just a 1, right? So when 10 is your base here, you log both sides, it just becomes, so log of 1/3 is this, and then you just plug in. So the magnitude of B will be 3.5 plus the log of 1/3, and that equals 3.02. Your check back is that if it's 1/3 is intense, then the magnitude of B has to be less, has to be a lower magnitude, right? If it's a higher magnitude, then it's more intense. Lower magnitude is less intense, and this is 1/3. That's not much of a movement, you think. Well, you're only down by 0.48, but it's 1/3 is intense, right? Okay. On from earthquakes to sound. Loudness of sound is measured in decibels. The loudness of the sound is given by the formula. dB is, so dB, deci, what's deci? It's the metric, no, that's deca. What's deci? What's centi? 1/100th, deci, 1/10. Okay, so a decibel is 1/10 of a bell. Named after? Alexander Graham Bell. Who, if he'd been Ricky, it'd be 1/10 of a Ricky. Nobody would name their kid Ricky anymore because it would just sound silly. Loudness of a sound is given by the formula dB, so decibels, is 10 times log of I over I naught, where I is the sound intensity and I naught is a reference intensity, which would be like the sound that you could barely hear, right? So a reference intensity sound. Sound is just movement and air pressure, right? It's really just pressure in the air. Okay, so they have this thing called decibel drag racing, where you just try to make the car as loud as you can, but it's got to be remotely controlled because you would die if you were inside of it because of the pressure. You know, so get up around. It's serious. You look up decibel drag. I'd go to Wikipedia now, but we already went there. You look up decibel drag racing, right? And these things, just cars filled with huge speakers, right? And,
Oh my god.
like the loudest sound, I think, is like a blue whale at not far from you, which would basically almost destroy you. It's louder than a jet engine up close. There.
Really a blue one.
Blue whales make a lot of noise. Since there are 10 decibels in one bell, another formula that could be used is you could use bells, which would be log of I over I naught. Look familiar? Same as Richter scale, right? So it's just a difference in intensities, right? Or sorry, it's comparing the intensity to something to a reference intensity. So for sound, reference intensity is just the sound that's barely audible. Okay, like, did I hear something? Anybody ever been in an anechoic chamber, an echo chamber? But it's designed to. It's weird, right? Like, yeah, because you walk in, so it basically has like foam and stuff that absorbs all sound.
Oh yeah.
So you walk in and it's really weird.
In New York they have.
And you can hear his heartbeat in the video.
Yeah.
And like the world record's like 45 minutes in the one in like New York.
Yeah, like you go nuts, right? Because it's just, you're cut off from all sound and you're not used to that. No matter where we are, there is some sound and noise. Normal conversation, which we've all exceeded at this point, has a decibel level of approximately 60 dB, whereas a power saw has a decibel level of about 110 decibels. Determine how many times more intense the sound of the power saw is compared to the sound of normal conversation. Okay, so it's the same deal. It's 10 to the power of the difference between, now in this case not magnitudes, right, but you got the idea, right? Measurements on the scale, except these are decibels, so we got to convert them to bells, right? So we want to go 10 to the power of, so we're going to say the intensity of the saw compared to the intensity of the conversation is 10 to the 11 minus 6. So we convert 100. So if you're ever working with decibels, just remember to divide them by 10. Okay? So it's 10 to the power of 11 minus 6, which is 10 to the 5th, which is 100,000. So a power saw is 100,000 times more intense in sound pressure measurement than normal conversation. So right now, I'm at normal conversation level. So 100,000 times more intense than that. Really? That's it for decibels? We can't stop there. Let's go look up decibels. Here, decibels. Here's another. Here we go. So a pin falling. You ever heard a pin drop? Pin falling is 15 decibels. Rustling leaves outside. Not now. There's no leaves to rustle, but that's like 30 decibels. Refrigerator humming. Even because well, it doesn't know the words, so it has to hum. Electrical transformer. We've all heard the hum of one of those 45. Got to get some occasionally. Floor fan 50, air conditioner unit 60. They say conversation is 65. City traffic 78, so just go stand, elbow in the thing. Vacuum cleaner 80, lawnmower 90, tractor or a hand drill 97, motorcycle 100, rock concert 105, chainsaw 110. Hammer drill 114, pneumatic, jet taking off 140, 12 gauge shotgun 160.
What about that blue whale?
I know, why is the blue whale not on here?
Do command that.
Somewhere there's going to be a chart showing relative sound.
188 decibels.
No.
Brad said it's 188.
180? Okay. 188. So the interweb says the blue whale's 180 what?
188.
188. And we had the jet taking off was 120. And the shotgun was one, and I actually stupidly fired a shotgun with no hearing protection. With what?
Can you search up, like at what point your ears start to get damaged by the sound?
Sure.
Well, you said you survived the shotgun.
Yeah, well, but you'd have temporary hearing.
Well, you can watch like drama. So they don't shoot a real gun.
Okay. Sounds of less than 75 decibels, even after long exposure, are unlikely. Repeated exposure to sounds at 85 or above can cause hearing.
How much is it as a
Okay. Concert's 105. You really should think about using some sort of hearing protection. All right, so here we go. 12 gauge shotgun. So if you worked in a factory which had 85 decibels, you could be there for 8 hours. If the level were 100 decibels, then you should be spending, without hearing protection, 15 minutes. If it's 115 decibels, less than 30 seconds. Right? That's permissible exposure time based on the NIOSH.
What's that 115 decibels?
115 rock concert, yeah.
It's gonna be different.
Here's a database of over 1,700 sounds. So 0 decibels is the softest sound you can hear, right? Which is also going to vary because your hearing is better than my hearing because as you get old, you lose, especially the upper frequencies, right? Like you here, wait. Well, I gotta pause this though. Hang on. Can't. Oh, so well, we could do blue whale versus shotgun, right? What was blue whale? Oh no, it's 188. So if we did blue whale versus shotgun, it'd be 10 to the 18.8 minus 10 to the 16, which is 10 to the 2.8, which would be 700, 800, something like that. I don't know. So you have to work it out. Do it 10 to the 2.8. 630.96. So blue whales are louder than shotguns.
Can you search a video of blue
Okay, after we're done.
Because
Yeah. See, they make their sound underwater though because, right? Because they live there, and you know, you then are causing. You're just, I mean, you can hear underwater, right? It's the same deal. It's still a propagation of a disturbance in the force in the water, right? You can hear it there. Right? pH scale measures acidity or alkalinity of a solution. Logarithmic scale base 10. The pH, so which just means that every movement of 1 on the scale is 10 times more or less intense, depending which way you're going. pH of solution scale measures relative acidity compared with the pH of neutral water, which has a pH of 7. So your basic distilled water. Or there are 4 ways in which. So as you know, most of you know, as you go down on the pH scale, you are increasingly acidic. As you go up, you're increasing alkalinity. If we wanted to ask you a question that involved this, we'd have to pretty much give you this, right? Because you can look at it, there are 4 ways we can describe the relation between a pH of 5 and 6. So we could say a solution to pH of 6 is blank times as alkaline as one with a pH of 5. So are you getting more alkaline or less alkaline? More, right? You're increasing. So it's going to be 10 times. The difference between 6 and 5, right? An increase of, or a decrease in this case of 1 is an increase in alkalinity of 10 times. Or we could say a solution with a pH of 6 is blank times as acidic. So if we've gone this way, it's going to be 1/10. Okay, so if you move from 5 to 6, you're 10 times more alkaline, but if you go 5 to 6, you're 1/10 as acidic. Solution with a pH of 5, so if we go from 5 to 6, are we getting more acidic? Getting more basic, so it's 1/10. And if we go from 5 to 6, are we getting more alkaline? Then we go 10 times increase in alkalinity. Oh, did I flip those around? pH of 5 is more acidic, right? Because it's got a lower pH. So sorry, I flipped those. And a pH of 5 is less alkaline, right? 1/10. So you've all seen this formula, I'm sure. So pH is negative log of H plus, where H plus is the hydrogen ion concentration in the solution in moles per liter. I was figuring when I was in high school, they just made this stuff up. Right? It's like you're making stuff up. 6.28, what is it? 6.28 times 10 to the 24. See? They might have made it up, but I still remember it.
It's 6 times 6.02 times 6.23.
Oh, really? All right. See, I don't remember it that well. The more acidic a substance, the blank the concentration of hydrogen ions. So if it's more acidic, does it have more or less? So it has more, the higher. So it's got a higher concentration of hydrogen ions, but what happens with the pH level? If you're going more acidic, you're getting a lower pH level. Hence, the negative coefficient, right? Turns things around. Word's gotten route about the pencil art. People are coming from all over. As the acid level in the substance blanks, the pH blanks. So the acid increases, what happens to pH? It decreases. So increases, the pH level decreases.
Wouldn't both answers work in that case if you go with this?
Yeah, they're saying the same thing, right? Use the information above to answer the following questions. Determine the pH of a solution rounded to the nearest tenth. So this is really just a straight substitution in the formula,
What if I
right?
didn't take chemistry? I wouldn't have to do this.
Yeah, so if you didn't take chemistry, they would give you this for say pH is defined as this, and then they give you this. So it says calculate the pH. So you write down, all right, so I know that pH is equal to negative log H plus, which is negative log 5.7 times 10 to the negative fifth. Okay, and you can just plug that into your calculator, which you've done in chemistry many times, I'm sure. And if you do, to save time, we'll get 4.2. Determine the hydrogen ion concentration if the pH is 6.2. So this is more applicable to us, right, in using logs. So in this case, pH again, just start with the formula. So we have to find H plus, but we know the pH is 6.2. So 6.2 is equal to negative log H plus. What's the first thing you should do? Divide by negative, multiply by a negative. So if I said to you, hey, 3 times something is equal to 48, what do you think? 3 times something is 48. Yeah, that something is 16. And then you solve from there. Don't do silly stuff. So it's 3x to the negative 2/3 is 48, and all of a sudden we're taking logs and we're divide the 3. So isolate the thing you're trying to find has to be isolated, right? Isolate the x, isolate the h plus. Well, it's still in the log, but we got to isolate. So we get rid of the negative. And now you say, okay, that means that, wait, what's this base? 10, right? So 10 to the negative 6.2 is equal to h plus. So h plus is 6.3 times 10 to the negative 7 moles per liter. Okay, so the concentration, the hydrogen ion concentration of an acid at the pH of 6.2. Yeah. Determine how many times more acidic is a solution with a pH of 4.3 than one with a pH of 6.2.
You wrote 6.3.
6. I got 6.3 here. What should it be? 10 to the negative 6.2?
No, I got 6.3.
Okay, try again.
That's right.
More people saying that this is right. And it agrees with it. I mean, this key is not always right. Okay, how many times? So we just apply the deal, right? So it's 10 to the power of 6.2 minus 4. So 4.3 is more acidic because it's lower. So I want to take higher pH minus lower pH because I want to get a positive, I need something that's going to be higher. So that's 10 to the 1.9, which is 79.4 times as intense. I don't know if they throw pH on there much. I mean, you can use Richter Scale, and then it's like everybody's on the equal footing. Solution A is 400 times more alkaline than solution B, which has a pH of 12. So if you got a pH of 12 and you're more alkaline, it's going to be bigger than 12 or smaller than 12? Okay, it's going to be bigger than 12. So what we want to say then is 10 to the power of the pH of, what are they, pH of A minus 12 is equal to 400. Right? So we know we need a higher number, so we'll do the higher number minus the lower number. Okay, how do we solve this? Take the log of both sides. So it becomes the pH of A minus 12 times the log of 10 is equal to the log of 400. What's the log of 10? 1. Right? So that's the nice thing when you're working with these scales and they're based on a base 10 or logarithmic scale with a base of 10, is that when you move the exponent down, it's just times log 10, which is just a 1. So then the pH of A is simply log 400 plus 12, which is what, 14.6. Okay, to the nearest 10. Solution A is 30 times more acidic than solution B, which has a pH of 12. So who's got the higher pH, the 12 or the solution A? So if it's more acidic, it has to be a lower pH, right? So now this time we want to go 10 to the 12 minus pH of A is equal to 30. Okay, so the intensity, we're going the other way this time. We know we're going to have a lower intensity, we'll figure out. Then we just plug it into the calculator. It's just 12 minus pHA is equal to log 30. So 12 minus pHA log 10 equals log 30. And so what's it going to be? So pH of A is going to be 12 minus log 30, which is 10.5. Okay. Other examples. Back winner. Sorry, I'll leave that up for a second. So we've got 3 other examples there, and then Omelchek said I should do one with compound interest, because people always mess that up. What's that? There's 2? So if you do one more then.
Do the compound interest.
Oh wait, there's 2. Oh, right, 2, then we'll do a third. So sorry. So we have 3 more, the 2, and then 1 additional one. Other examples. To view an eclipse of the sun. Did anybody see the one we had, like, was it last year or something? I think Furstenberg bought his telescope with the sun filter, which is nice because you can just look through that. But if you wanted to look at it, they had those Mylar little glasses you could wear, I think. Safest thing would be to get some number 14 welding glass, right? So when welders weld, there's an arc that is very bright as the sun even, right? So you don't want to be staring at it because you'll go blind. So they use welding glasses to protect their eyes. The shade number of welding glasses relates to the fraction of visible light transmitted through the glass, right? So how much light gets through. The relationship is given by the formula. Shade number is -7 log t over 3 plus 1, where t is the amount of visible light transmitted, and we're supposed to figure out how many through number 14 welding glasses. Express the answer in scientific notation to 3 sig digs. So 14 is equal to -7 log t over 3 plus 1. Step 1, you want to solve. What are you going to do? You want to isolate the log t. You got to get it by itself. What's your first thing? Get rid of the 1. Subtract 1 from both sides, right? So 13 is -7 log t over 3. Log t. Okay, multiply by 3, divide by -7. So 39 over -7, or -39 over 7, right? So 3 times 13 is equal to log t. What's t? 10 to the -39 over 7. And So I'll just use the value I have written here. 2.68 times 10 to the negative 6.
Wait.
So 10 to the negative, that's like 1/2 millionth or something, or like 0.00000. So not much light's getting through, which is what you want if you're looking at the sun. You don't want much light getting through. Okay, but you can see the moon start taking a chunk out of the sun. If it's a total eclipse, which is not all that often, yeah. Like total lunar eclipse, that's a dime a dozen, right? You get a couple of those a year, I think, most times. But total solar eclipse, very rare. We traveled, especially when it was cloudy. Population of a town can be modeled by the function P of t is P naught log base 3 t plus 1 plus 1. You're sometimes going to be, next year you'll be sitting there reading a textbook and going, where do they come up with this stuff, right? Like there's these formulas, like why do you, like I know what it is because we studied in math, but why is it log base 3? You're more likely to actually see an ln or a log base e, right? We haven't done e, have we? No, okay. We will next course. But log 3 t plus 1 plus 1, where t is the time in years since January 1st, 2007. P0 is the initial population. If the population in the town was 800, determine the year in which the population reached 2,500. Okay, so we want to end up with 2,500. So that's going to be our population after time t. We start with 800. We got some square brackets. We've got log 3. Determine the year in which. So t is the time in years, so we don't know this. So we're trying to solve for t. So what's the first step if I want to isolate the t? Divide both sides by 800, right? Okay. So 2,500 over 800 over 800 is equal to log base 3 of t plus 1 plus 1. Next step, get rid of the what? Get rid of the 1. So now we're going to subtract 1 from both sides. So I'm going to leave this in a form that could go in my calculator. I'm not, is equal to log base 3 of t plus 1. Next step, get rid of the log. So how do we do that?
3.
So 3 to the power of this. So 3 to the power of 2,500 over 800 minus 1. Yeah. What is the decimal? 2.125. So 3 to the 2.125 minus 1 will equal t, right? We got the t plus 1, move that over. And so what's t? 3 to the 2.215 minus 1.
Yeah, 9.3.
9, no, was it 9.32? Okay, so the question is, in which year?
Year 10.
No, well, 9 years after
Yeah.
January 1st, 2007, which is?
What about the 32?
Well, so that's going to be 3/10 of a year into, it's still going to be 2016, right? So if this is January 1st, 2007, if this is any number less than 10, so between, like this could be 9.01 to 9.99, it would still be in 2016, right? So the year is 2016. This is 3/10 of the way into the year, right? Which is 3 times 30, so 108 days in. So, I mean, you could work out where you were in the year, right? Just go 0.32 times 365, and it'll tell you what day. If this were 9.75, I wouldn't round this to 2017, right? If this were 9.99, I wouldn't make this 2017. It's still going to be in. If this were 9.99, it might be December 31st of 2016, but it says what year? Well, it's still in 2016. Okay, so watch out for that if you're doing questions along these lines, don't just say, oh, that's 9 point, if it were 9.75, or something around that to 10. You don't want to do that.
Do we need to memorize the formulas for like earthquake intensity and pH?
No, I think if they're gonna like something like this here, they're gonna give you the formula.
Well, yeah, but like I think earthquake.
If they do an earthquake intensity, then you're gonna be looking at something like this. They'll give you a text box at the top telling you about it.
So we don't need to.
You don't need to memorize. What you need to know is I just got to go 10 to the power of the difference between the magnitudes.
Yeah.
But then they're not going to ask me that because that's too easy.
Oh.
So they'll give you the intensity and they'll make you figure out one of the magnitudes, right? And you just say, so I'm looking for a larger or a smaller magnitude. Just make sure it's 10 to the power of larger minus smaller. Gives you a positive. Okay, so the last one I'm trying to do is like a financial application. So a deposit $1,000 is deposited in an account that pays. What was the rate you were going to be getting?
Well, annually or?
It was like 12% over
Yeah.
4 years. So let's say 4% annually or something.
It doesn't compound though.
Yeah, I know, but so we'll compound. So okay, let's go 3.7% per year, compounded monthly.
It's just 3.7 divided by 12.
Not quite. Account pays for service. How much will we have? How much will we have in, say, 12 years? So you start school, your parents put away $1,000, they get this 3.7% compounded monthly. You're graduating now, and they're saying, here, have some money. How much money? Will this cover your tuition? Will it cover your books? Will it cover your meals? We don't know, right? So let's figure out how much money will we have.
Yeah, well,
That's way too much.
not compounded monthly, but
Yeah, no, you're not. Trust me, it's not that much.
0.7%.
in the 80s you could get.
So
that.
formula, yeah, it'd be tough to get this interest rate right now.
So you had like $1 million. Makes sense.
Oh, if I had $1 million.
Well, I don't know. Like some stocks pay dividends of this much.
Okay, so this is the growth / decay kind of formula you're given. Or do they say? What do they say here? It's just okay. It says growth / decay formula. So it really is the growth / decay formula. They're giving it to you, right? And so you say, all right, I remember some stuff about this, like the $1,000. That's my initial amount. I'm getting interest, so it's 1 plus. But now here's how compound interest works, right? You have to take the percentage, divide it by 100 to change it into a decimal. And then we're compounding monthly, so we have to divide that by 12. Okay. Wait, now instead of how much will we have in 12, let's change that to how long will it take to get, okay, how much money do you want? We'll figure like, how long will it take to get to how much money?
$10 grand.
$1 million. 10. Let's go with 10,000. We might live to see that happen. $1 million. How long will it take to get to $10,000? So we're going to put a little t up here. Well, you know, we sort of put a t over p. And actually, well, we know what the p is, right? It's like t over 12. And this will be the 10,000 that we want to end up with. So we're going to end up with $10,000. We started with the 1,000. This is the important point number 1. When you're doing interest, compound interest, take the interest rate as a percent, change it to a decimal. If we're compounding, monthly you divide by 12. Actually, let's do 12t. So monthly we divide by 12. If it were quarterly, we would divide by 4. If t is my time in years, then I need to convert it to months. So I'll multiply by 12. Okay? So that this time period, the compounding time, which is months, has to match this, which is also month. If I just put a t up here, I would just have to recognize when I get an answer, it's going to be in months. Okay? Now, wait a second. If that's months, then yeah, really, I do want t divided by 12. Never mind.
Yeah.
Yeah, t over 12. So now t's in years. If I just left this as a t, we would get the time in months. If I want to end up with the time in years, then the t.
I didn't start.
Or 3 months. Never mind, you're just going to mess these questions up because I sure as heck can. Let's just leave it as a t, then we'll figure out. Let's just, if we do it as t, then we're going to get the time in whatever units this is in, which will be months. Then we divide it by 12, we get years. Okay? Okay, so 10,000 divided by 1,000 is 10. 1 point. 1 plus, so what's 0.037 divided by 12? 0.03083. So right, so you're just gonna leave that number in your calculator, right? You're not gonna write that out to the t. Okay, how do we solve for an unknown exponent? Log, so we get log 10 is equal to t log number. Log 10 is just 1. Okay, is equal to t log number. So t is equal to 1 divided by the log of the number that you got there, 1.003, etc. Okay, so what's t? 1 divided by log the second answer. 747.9. Let's call it 748. Now that's months. So yeah, it really was a 12t up there then. That would have been. And so we divide by 12 to get years. Divided by 12. Oh, which has already been done for me. So 62 years. Don't go for the $1 million. You'll never live to see it. 62 years. 62.3 years. Okay. So just big thing to remember, if you're doing anything with compound interest, this is the big thing. Just leave this as a t and just remember it's in the same time units that your compounding is. So if this were quarterly, I would divide this by 4. This would be quarters, and then I would divide it by 4 to get years. Okay, so actually it would be a t over 4. Okay, just leave it as a t.
So whatever the denominator for that is, you divide t by. So it's over 12 months, you do t over 12. T over 12.
So if t is in months, you go t over 12 to get years. Yeah.
Okay.
No, you'd have to go 12t.
Oh, 12t. Okay.
Yeah.
Just 3 to 7% slash a.
Yeah.
That's
Okay, slash a. So this is per
year.
annum, Latin. So it's per annum, which is the root word for annual, which is per year. Yeah. So you might see if you ever have a chance to look at a newspaper, and you see interest rates advertised, you look at the bottom, it'll say the nominal interest rate of whatever slash a, or okay, which means per annum or per year. So interest rates, other than that one ad you were looking at, interest rates are always given as a yearly interest rate. Okay, and then they could be compounded. So if I got 12% a year and it was monthly, I'd get 1% each month. Right? And it will compound, which means at the end of the month they calculate the interest and they'd stick it into my account. And then the next month I would earn 1% on that slightly increased amount. That's why compound interest is exponential and does this. Okay. That's how you get the 1 penny to hundreds of trillions of dollars in 1,000 years. Even with a 4% interest rate.
Actually.
Was it? Yeah, see? Like, if you knew, I would leave to my future self.